Hello, my name is Bill Bowen and I'm a project management instructor here in Ottawa, Canada. This video explores some of the concepts behind earned value management. I have created this video to assist my students in understanding earned value management and how it can be utilized within their project management status report assignment. I will also explore some of the limitations of earned value management. The information presented in this video aligns with the approach outlined in the 5th edition of the PMBOK. I have supplemented the PMBOK's material with knowledge gained through my own personal experiences utilizing earned value management throughout my career. I hope you find this video useful. Let us begin by first understanding what the goals of our status report are. We know that our status reports need to provide our stakeholders beneficial information that addresses their concerns and questions about the project, and that the information our status reports contain will be used as part of the decision-making process for the project. Our status report needs to answer questions like, what is the status for each of the individual tasks and deliverables on the project? Are we ahead or behind schedule on this project? Are we over budget or under? Has the estimated cost for this project gone up or down? And we know that our status report will be read by a range of different stakeholders with different degrees of understanding of project management tools and techniques, and different expectations and needs with regards to our status report. Therefore, our reports need to be accurate, clear, concise, quantifiable, verifiable, and of course easy to understand, easy to read, consistent, and have a very standardized approach. As professional project managers, what we try to avoid are reports made up of subjective, non-verifiable conjecture, such as simply stating that we feel things are going well on the project. Such subjective statements are usually inaccurate, can mislead our project stakeholders, and are rarely useful or helpful, and certainly not something you would want to make a project decision based on. Fortunately, an approach exists that will allow us to produce status reports that fulfill these goals and requirements. Earned value management is an established and accepted method of tracking and monitoring a project's performance with regards to its cost, expenditures, and its schedule. Earned value will allow us to produce the accurate, consistent, concise, and easy-to-read reports that we need. And it can be used to display the project's status, detect problems and trends within the project, and estimate the impact of these problems and trends will have on the project. But earned value is not simply another way of reporting data. It is an approach or system that, to be effective, must be integrated into each stage of your project. Early on in your project, during the project initiation stage, the project charter should identify earned value as being an integral part of your project's reporting structure. During the planning phase for your project plan and its task definition should be set up with earned value in mind so as to maximize its effectiveness. And the overall scope of the project or its work breakdown structure must be stable enough to support earned value. The benefits of setting up our project to accommodate earned value is that we will now be able to use the tools and techniques that I will outline in this video to produce very practical and useful reports during our project's monitoring and controlling phase. These reports will help fulfill our project's reporting requirements, not only during the project's monitoring and controlling phase, but also during the project's closeout phase, where we will once again draw upon the information gained through our monitoring of the project's earned value to produce lesson learned reports that will be helpful in later phases of the project, but also on future projects. So let's now look at the agenda for this video to see how we're going to explore more about earned value. The agenda for this video includes defining the 3 basic tenets of earned value management, those being planned value, actual cost, and earned value. These terms are frequently referred to by their acronyms of PV, AC, and EV, respectively. Please note that you are also likely to encounter older expressions for these 3 terms, these being budgeted cost of work scheduled, actual cost of work performed, budgeted cost of work performed. These were the original terms used within earned value management and persist today out of tradition and the fact that some of these older terms are preferred as they are more descriptive in nature. These older terms are equivalent and synonymous with the newer terms and can be used interchangeably. We will also look at the variance formulas, those being cost variance and schedule variance. We will also explore the 2 performance indexes, the Cost Performance Index and the Schedule Performance Index. And we'll look at how earned value can be used in forecasting, in particular estimating the cost to complete the project and the cost of the project once completed. And in the last section of this video, we will look at an example of how earned value can be used to produce information useful in the status report. We'll also look at why earned value works the way it does, and I'll provide a few words of caution on some of the limitations of earned value. So let's begin our studies of earned value by taking a look at the key foundation from which earned value must be based upon. Throughout this video, I will be utilizing the simple WBS with its 3 deliverables and 10 tasks as the basis for our earned value analysis. For earned value to be effective, it must be based on a mature work breakdown structure that accurately reflects the deliverables and tasks associated with the project. If the WBS is likely to experience major changes during the life of the project, with new deliverables and tasks being added and older ones being modified or removed, then utilizing earned value analysis will become very challenging, as it must have a solid, stable baseline to compare project progress against. For this video, we will assume that we have a very mature work breakdown structure that will not change over the life of the project. We can further refine the project that we will use in this video by assigning duration and predecessor to each of the tasks that we defined in our WBS. Furthermore, we can allocate funding for each of these tasks. I have shown the labor cost and material cost for each task and calculated the total cost for each item in the WBS, as well as the project as a whole on this table. To help visualize the project that we will be using in this video, I have created this Gantt chart that shows a visual representation of the project's dependencies and budget. Notice that the project's overall duration will be 10 days with an estimated budget of $3,600. It helps to think of the budgeted cost for each WBS item and the project as a whole as the value associated with each item and the project. The concept that the budgeted cost of the project and its tasks represent value is key to understanding the concepts behind earned value management. Now that we've defined the project that we will be using in this video, let's take a look at some of the basics of earned value. We can begin our exploration of earned value by first looking at planned value. The PMBOK defines planned value as the authorized budget assigned to the scheduled work. Planned value is simply the budgeted cost of each WBS item and the project as a whole. Another way to look at planned value is that at any given time, the planned value for a task or a project is simply the value of the work that should have been accomplished on the project or task up until that moment in time. But this creates a problem for us. How do we assign a budget value to a task at any given time during the task's execution? We accept that as we spend money on a task or a project, we're to think of this money as bringing value to the project. A worker who works for a day on a task is thought to have brought a day's worth of value to that task. If we purchase $1,000 worth of supplies for a project, then we think of this as bringing $1,000 worth of value to the project. Thus, the value that a task brings to a project is equal to its assigned budget. The goal of planned value is to determine the value of the work that should be accomplished at any particular point in the project. Within a task, it would be very challenging, if not impossible, to implement a literal interpretation of the goal of determining a task's value at any particular point in time. The reason this would be so challenging is that funds are spent and value is added to a task on a nonlinear fashion. For example, the moment you purchase supplies or equipment for a task, there would be a jump in the value added to that task. Similarly, if you were to bring a subject matter expert onto the team for a short period of time to strategize with the team on how to overcome a particular problem, the expenses charged by that subject matter expert would result in another jump in the value to the project. A task might be put on hold for a few days or weeks, during which time that task adds no value to the project. Attempting to define in detail such a sporadic assignment of value within a task would not be practical. As such, we need a more structured approach to assigning value to a task. One of the most commonly taught methods for assigning value to a task is the 50-50 rule. This is where half the value of the task, or 50% of its value, is awarded for simply starting the task. The remaining 50% of the value of the task is rewarded upon completion of the task. This approach is common, as you have no doubt heard of contractors calling for half the value of the job up front, or on the start of the job, and half upon completion. We use this 50-50 rule to bring a more structured approach for assigning the budgeted value to a task. At the end of this video, I will examine in more detail why we use this rule and why it is frequently taught, why it works, what are the shortcomings of this rule, and what are some of the alternatives to this rule. In this slide, I have taken the budget that I presented a few slides ago and mapped it onto the Gantt chart using the 50-50 rule. What you see here is that each task is awarded half of its value upon its start and half of its value upon its completion. The result of which is I can now create a time-based budget that shows a profile of the accumulated value being added to the project over the duration of the project. As each task begins and ends, its value is added to the cumulative total project value until we reach the project's expected total budget or value of $3,600. This profile is thought of as the project's planned value. On any day of the project, I can see how much value the project should have accumulated. This profile gives us the basis for comparing how the actual project has progressed. This slide shows our planned value time-based budget. We can see in this example that we have approved the investment of $1,625 worth of combined labor and material expenditures into the project by day 2. We think of this as the project having earned that amount of value by day 2, and the project will continue to accumulate value throughout its duration. We now move on to the next concept, which is to define what we mean by earned value itself, often simply written as EV. This term used to be called the Budgeted Cost of Work Performed, or BCWP. Due to the fact that many people like the descriptive nature of BCWP, you will still encounter the acronym in use today in business. The two terms are synonymous. The PMBOK describes earned value as the measure of work performed expressed in terms of the budget authorized for that work. When determining how a project actually earns its value, we use the same rules that we did with planned value for determining how value is earned. But we allocate this value to a project based on when the tasks were actually performed, and not when they were planned to be performed, as we did in planned value. So let's look at how value on our little project was actually earned, and we see that things did not go according to plan. I have provided a tracking Gantt that shows the original project scheduled for its 10 tasks in the lighter color and the actual execution of the tasks in the darker color. What we see is that many of the tasks were delayed or took longer to perform than originally planned. Other tasks were compressed in an attempt to recover from the slow start. When determining how the project earned its value, we ignore when tasks were originally planned and only consider when they actually occurred. We then apply the same standard for determining value that we utilized earlier with planned value, but we apply this value earning standard to the tasks based on when they actually occurred. By mapping out the project actually earned its values onto our time-based budget, we get our second profile. The first one, shown in the lighter color, was our planned value, which we explored earlier. But the new one, shown in the darker color, represents how value was actually earned on the project. The difference between the two profiles reflects the delays, slippages, and task duration compressions that were actually encountered during the project's execution when compared against the original plan. What we are seeing in this graph is the first steps to quantifiably comparing our plan to what actually happened. So we now have a way of showing the project's planned value along with its earned value on a time-based budget. What we now need is a way to show the project's actual costs. When we have this, then we have a way of comparing the project's performance in terms of its budget, schedule, and actual costs. Thus, the last piece of the puzzle is to define this actual cost, or AC, sometimes referred to as the actual cost of work performed. The PMBOK defines actual costs as the realized costs incurred for the work performed on an activity during a specific time. In short, To be able to effectively monitor, control, and report on a project, we need to know how expenditures are occurring on that project. In this slide, I am showing the actual costs incurred by each task on the project. What you can see is that many of the tasks experienced cost overruns, while a few were brought in under budget. The total actual cost for the project is simply the sum of the actual costs for each individual task on the project. You might be wondering, where do these actual costs come from? Within a business environment, information on the project's actual costs are usually obtained by reviewing the project's invoice for material and services, along with timesheet data for the team. Hopefully the organization has an information system in place that makes retrieval of such data fairly easy. Within an academic environment, actual costs are usually either simply given to you within the problem, or the problem provides you a means to calculate the actual cost. For example, stating that the actual costs are 10% more than the planned costs. Now that we have the actual costs for this project, we can map those costs onto the project tasks. Since we don't know the cost of the task in advance, we can't apply the 50-50 rule. We simply have to consider either the task's cost to date or the task's total cost once it's been completed. Using this actual cost data, we can now create our third profile on our graph. We can see how much value a project was supposed to have earned on any particular day compared to how much value it actually earned and how much it actually costs to earn that value. By bringing a project's planned value, earned value, and actual costs together, we create a standardized and quantifiable means of analyzing and reporting on a project's performance. A visual inspection of this graph tells us quite a bit about the project. With the actual cost profile of the project being higher than that of its planned value, you can already surmise that the overall cost of the project was higher than what was originally planned. And you can most likely also recognize that before day 8, the project was running behind schedule as its earned value was less than its planned value. But what do these gaps or variances between the various profiles mean? There are two types of variances that we can detect: a cost variance and a schedule variance. Let's learn more about what these variances can tell us about the overall project. The first variance that we're going to learn about is cost variance. The PMBOK defines cost variance as the amount of budget deficit or surplus at a given point in time expressed as the difference between the earned value and the actual cost. Thus, the formula is simply the difference between its earned value and the actual cost. To help visualize the cost variance, I will perform the calculations on day 7 of our project. I picked this day simply because there is a greater separation between the actual cost and the planned value on this day, and it will help us to see the variances more clearly. Thus, the cost variance on day 7 for the project is simply the value that it had earned on day 7 minus the cost that the project had incurred by day 7. In our case, the cost variance works out to be minus $680, which means that by day 7, our project was already over budget by $680. Or it had taken us $680 more than we had originally planned to achieve the value that we have obtained by day 7. Similar to cost variance, we can also calculate our schedule variance for the project. The PMBOK defines schedule variance as a measure of the schedule performance expressed as the difference between the earned value and the planned value. Let's see how this works. Returning to our graph, we can see that our schedule variance is simply the difference between the value that we've earned so far on the project and what we had planned to earn by this point in the project. For our project, the schedule variance works out to be minus $175, which means we're behind schedule. Intuitively, we can visualize this as the value that we planned to have earned by this point in the project is more than we've actually earned. Bringing both variances together, we can see that as of day 7, the project was behind schedule and over budget. We know this because the actual cost line for the project is greater than the project's earned value, which means it's over budget. And the project's planned value is more than what was actually earned. Thus, it was behind schedule. This table summarizes how project variances should be interpreted. If we have a negative schedule variance, it means that the project is behind schedule, while a schedule variance of 0 means that the project is going according to plan. If we have a positive schedule variance, it means that the project is actually ahead of schedule. Similar interpretations can be applied to cost variances. As such, a project with a positive cost and schedule variance would be both ahead of schedule and under budget. While cost and schedule variances are great tools for conveying the project's performance, interpreting them can sometimes be misleading. Consider the following example. In the first case, we have a project with a total budget of $10,000 and a schedule variance of minus $1,000. This means that the project is 10% behind schedule, as it has earned 10% less value than it had planned to earn by this point in the project. Most project managers would consider this a serious scheduling problem. In the second case, we have a project with a total budget of $1 million and a similar variance of minus $1,000. But in this case, the project is only 0.1% behind schedule. For most project managers, this would be a minor variation at most in the project schedule, certainly not worth worrying about. So we have two projects with the same schedule variance, and in one case it is a serious problem, in the other it is a minor one. Clearly we need a means of conveying scheduling and costing information that takes into account the project's overall budget. Fortunately, the PMBOK provides us two such performance measures. The first deals with schedule and is called the Schedule Performance Index, or SPI. The PMBOK defines it as a measure of schedule efficiency expressed as the ratio of earned value to planned value. The second is the Cost Performance Index, or CPI. The PMBOK describes this as a measure of cost efficiency of budgeted resources, expressed as a ratio of earned value to actual cost. So let's see how both these indexes work. By returning to our graph, we can calculate the Schedule Performance Index for Day 7 by simply dividing the project's Day 7 earned value with its Day 7 originally planned value. We see that the project's original planned value for Day 7 was greater than what it was actually able to achieve. As a result, its Schedule Performance Index, which is simply a ratio, is less than 1, 0.94 to be exact. An easier way to think of this is that the project is approximately 6% behind schedule. The performance index value can be converted to the more familiar and comfortable percentage form simply by multiplying it by 100. Similarly, we can determine our cost performance index for the project by simply dividing the Day 7 earned value by the Day 7 actual costs. This produces a CPI of 0.8, which means we've only obtained 80% of the project's value, given how much money we've had to spend on the project. As with our Schedule Performance Index, it is quite often easier to convey a project's CPI value if you convert it to a percentage. With our project, our CPI of 0.803 essentially means that the project is approximately 20% over budget. Everybody understands CPI values when it's expressed this way. When viewed together, the two indices can provide a very accurate picture of the project's current status. I have updated the table I presented earlier, but this time I've also included the SPI and CPI values. As you can see for our project, with its SV of minus 175 and its SPI of 0.941, combined with its CV of minus 680 and its CPI of 0.803, it means that our project is both over budget and behind schedule. Ideally, you would love your project to have a CPI and an SPI of 1. This means it's on budget and on schedule, although it is normal to have some variations in any project at any given point in time. Earned value allows you to track the trends that occur on a project to determine if variances are simply a one-time blip or part of a systemic trend that you need to deal with. But earned value is more than simply tracking trends and detecting variances. It can be used to update your original estimated cost and durations for your project based on actual project performance to date. So let's see how that works. The first forecasting tool that we will examine is how earned value can be used to project the estimated cost of a project at its completion based on the costs incurred to date. The PMBOK defines this estimated at completion EAC, as a way of expressing the expected total cost of completing all work as the sum of the actual cost to date and the estimated to complete. This particular method of estimating the project's total cost is based on the assumption that any variations in the overall project costs that have been encountered so far in the project were one-time abnormalities, and that the project as a whole is expected to carry on as originally planned from here on in. Now let's see how this would work. We will continue to use day 7 of our project as the basis for estimating what the project's overall costs are most likely to be based on the actual costs that we've encountered up to and including day 7. The costs that we've encountered so far are fixed. These funds have been spent, and this cannot be changed. So I like to think of the actual cost to date as sunk cost. The money is gone, and whatever value it has brought to the project is all that it's going to bring. We also know how much value the original project was planned to have, and how much value it has earned. These 3 data points are all that we need to calculate a new updated overall cost for the project. Using our new formula, we can estimate an updated overall cost for the project at completion. This new estimated value would be based on the actual costs that we've encountered to date, plus the overall value that the project was intended to have at completion, minus the value that it has gained to date. If we perform these calculations, we discover that the new estimated cost for the project would be $4,280. Keeping in mind that originally we planned our project to only cost $3,600, this would mean that the new estimated cost would show that our project is going to come in $680 over budget. But remember, this estimate is only valid if we assume that our original plan is still valid, and that the cost overruns that we've encountered to date are simply abnormalities. If all our original estimates were incorrect and invalid, then this approach to estimating the costs at completion is also invalid, and we need to find a different way to calculate how much our project might cost based on the fact that our estimates are systemically incorrect. Fortunately, the PMBOK provides us such an approach. There is a second formula for calculating the estimated cost of a project at completion. In this method, we assume that the trend that the project has experienced to date can be expected to continue into the future. The work is assumed to be performed at the same cost performance index value that has occurred to in the past. Therefore, the estimated at completion cost is equal to the project planned value total divided by the cost performance index. Using this method of projecting the estimated cost of a project at completion, we simply take the original planned value for the project and divide it by the cost performance indicator that we calculated earlier. We see that this method gives us a higher projected overall cost for the project, that of $4,483. This is because this projection is based on the assumption that the cost overruns we've experienced to date will continue throughout the project. Essentially, this method is telling us that based on the day 7 values, all of our costs are likely to be approximately 20% higher than we had originally estimated, and thus the project as a whole will be 20% higher than we had planned. Which method is best? Well, that depends on how confident you are as to whether or not you are seeing a trend with your costs or you've simply hit a few unexpected expenses. We can now look at the last forecasting tool that I plan to cover as part of this video, and that's how to calculate the projected costs to complete. Essentially, what is the expected cost to finish all remaining work on the project? The formula is simply the projected estimated cost to complete the project, subtract the current value that you've been able to add to the project. For our calculations, I will assume that the cost overruns that we've encountered to date are simply abnormalities and do not represent a trend, and as such, the rest of the project will carry on pretty much as originally planned. Thus, I will use the first formula for calculating estimated at completion costs. And once I know the project's new estimated cost to complete, I can simply subtract the value that the project has been able to obtain to date to achieve how much it's going to cost to complete the project. Performing these calculations, I find that I'm now estimating it will cost an additional $1,505 to complete this project. One variation of this formula that is worth noting is that if I had encountered no cost overrun so far in the project, and as such my original estimate of the project's overall cost was still valid, then my estimated cost to complete would simply be the project's original overall planned value minus the value that I was able to achieve to date. In this example, the project's value on day 7. Thus, if my original estimates were valid, the project would have a projected cost to complete of only $825. Well, that was a lot of formulas in a very short period of time. Let's take a moment and review them. This slide summarizes the formulas that we've encountered so far in this video. To help give these formulas more meaning, I will now use them in a typical earned value example, similar to the type that are frequently encountered within academic earned value studies. I will first define another simple project, and then once again use these formulas to determine and calculate the type of information frequently called for within a status report. This would be the Gantt chart for the project that we will use. As you can see, it has the same project tasks that we encountered before. Our goal is to produce information that would be appropriate for a status report. Only this time we will not have all the information available to us that we had in the previous example. For this project, we will use day 5 as the basis for our status report. We will also assume that day 5 is the first day that we calculated earned value and actual cost for our project, and as such, we will not have previous earned value and actual cost values for days 1 through 4 to use within our status report. Let us begin by first looking at the project's original budget and determining what we had expected our project to have earned by day 5. As you can see, I have added budget information onto the slide. In the first column, you will see that the overall budget for the project is still $3,600, as it was previously in the video. Reviewing the Gantt chart, you will see that tasks A, B, C, and G were all supposed to have been finished by day 5, while task H was supposed to have been started but not yet finished. Using the 50-50 rule, I have reflected this task plan status information into the second column of the table. You can see that task H is marked at 50% complete, while the other tasks that were supposed to have been completed by day 5 have been marked as being 100% complete. In the third column, I have calculated the day 5 planned value. My original plan was to have added $1,975 worth of value to the project by day 5. Next, let's look at what value we actually were able to obtain by day 5. I have now added actual project progress onto the table. Again, as previously, things have not gone according to plan. As you can see, for some reason, task G has not been finished. It's been blocked. And all of its successors have also been blocked from starting. But apparently, resources have been shifted onto task A and its successors, and as a result, more progress has been made on those tasks than originally planned. Using the 50-50 rule, I have reflected the value that has been earned by the actual work done onto the actual status column of the table. Using the task's original budgets, I now calculate how much value each task has contributed to the project, and how much the project as a whole has earned. So far, the project has earned $2,275, which is actually more than what was originally planned, despite the fact that task G was blocked from being completed. The last thing to be added to our table is actual costs for each task. For this problem, I'm going to assume that these up-to-date costs are simply given to you as part of the problem. I have marked the costs associated with each task, even those tasks that were not originally planned to be started by day 5, but were in fact started and had costs occurred to them on day 5. Summarizing these individual costs shows me that the expense for the overall project on day 5 has amounted to $2,590, which is more than what we had planned for. Before day 5 totals are all the basic data points that I need to conduct my earned value analysis and prepare my status report information. I've replaced my Gantt chart on this slide with a new chart that shows me project value. I will then take my calculated totals of the project's overall planned value, the project's day 5 planned value total, the project's day 5 earned value and actual cost totals, and now map them onto this new chart. As you can see, the 4 values that I need to conduct my earned value analysis have been mapped onto this new chart. I will begin by first calculating cost variance, but to make my slides a little bit more readable, I will get rid of the project tasks data, as I no longer need it to continue with my earned value analysis. If you recall, cost variance is the difference between a project's earned value and its actual cost. As we are conducting earned value analysis on day 5 of the project, I will use my day 5 actual cost and earned value totals for these calculations. As you can tell by simply looking at the graph, the actual cost of the project is once again more than the value it brought. As a result, through this visual inspection, we can tell that the project is once again over budget. This is confirmed through our calculations, where we find that the project is $315 over budget, which is represented by a negative cost variance. Similarly, we can conduct schedule variance calculation on our day 5 totals. If you recall, schedule variance is simply earned value minus planned value, and as with our cost variance, we will use our day 5 totals for these calculations. By day 5, we had actually achieved more value for the project than we had originally planned. This can be seen in our graph, as our earned value is greater than our planned value, and is represented in our schedule variance calculations as a positive variance. In this case, we have a schedule variance of positive $225, which means despite the fact that we are doing tasks in a different order, we're actually ahead of where we planned to be. Next, we look at our performance indices, starting with our cost performance index. The CPI for this example would be the day 5 total earned value divided by the day 5 total actual cost. In our case, it shows that the project is approximately 12% over budget. This is consistent with what our cost variance also showed us, as it showed us that the project was over budget by $315. Next, we calculate our schedule performance index, which is our day 5 earned value divided by our day 5 planned value. For our sample project, we get some good news, in that it tells us that the project is currently 10% ahead of schedule, or that the project has earned $225 more than we had planned to earn by this point in the project schedule. Combined, the cost variance and cost performance index, along with the schedule variance and schedule performance index, all indicate that our project is ahead of schedule and over budget. And that is about all these indicators can tell about the current state of the project. Now we can move on to forecasting how much the project might end up costing and how much it will cost to complete the project based on its current performance. Let us assume that we have reason to believe that we have consistently underestimated all of the tasks on our project. Perhaps our team wages have turned out to be higher than we had originally thought, and as such all tasks are costing more to complete than planned. As we have previously calculated our day 5 cost performance indicator to be 0.878, we can now determine a new estimate for the project's total cost by simply dividing our project's total planned value by this CPI indicator. If our assumption is indeed valid, then the cost of our project should be somewhere around $4,100 once it's completed, and not the $3,600 that we had originally estimated. If our $4,100 estimate to complete the project is valid, and we have already contributed $2,275 worth of value to the project, then our estimated cost to complete the project would simply be $1,825, which is the difference between what we think the project will now cost and what we have contributed to the project already. One last number we can calculate is to estimate how much over budget we will be at the completion of the project. If the trend of everything costing 12% more than originally planned holds, then we will be about $500 over budget when the project's complete. This is the difference between our updated project cost estimate and our original project cost estimate. Pulling all this information together, we see that our earned value analysis has provided us with considerable amount of good information that can form the basis of our status report. At this point, rather than introducing any new concepts in this video, I want to go back and examine the whole idea of this 50-50 rule and why we use it. You might be asking, why do we use such a structured approach for determining value on a project? Why not simply ask the people who are performing the work what the status of their task is? Would this not give us a more precise assessment of the value being added to the project? Well, in some cases, this might be true. However, more often than not, it would lead to an inaccurate estimate. Remember, projects are unique endeavors. As such, people usually don't have a good appreciation of all of the efforts and problems that might come up later in the task. They also usually don't take into account delays and setbacks that can be encountered due to risks associated with that task. As such, they tend to only give subjective, ad hoc, or judgmental estimates for how things are going on their task. Keep in mind, it's human nature to overestimate our efforts and to underestimate the work remaining. Also, most employees have learned that managers go away and stop bothering them once they tell the manager that everything is on track, even if it isn't. As project managers, we need a more structured approach and cannot rely on a subjective approach to estimating value added to a project. Within a production environment, it might be possible to get a very accurate determination of the exact status of a task. For example, if you are required to produce 1,000 boxes and you have produced 624, then you are 62.4% through the task. However, in a project environment, given its unique nature, it is not possible to know, for example, if someone is 78% of the way through programming a user interface, as they don't know all the challenges that lay ahead in completing that task. Don't forget the 80-20 rule, which states that 80% of the effort is often required to finish the last 20% of a task. This rule often comes back to haunt us as project managers. You might be wondering why we award value to the project when a task is first started, even though at that point no actual work has been performed yet. Would it not be better to award value to the project at the halfway point in a task, or at some other point? First of all, we would not have consensus as to when we reach the halfway point of any particular task. There would always be those who would believe that the hardest part of the task, that which requires the greatest effort, is yet to come. The only two definitive points on a task that are easily measurable are when it's first started and when it's ended or accepted. Those are the only 2 points that we can measure and serve as the best points to award value to the overall project. Now, there are ways you can set up your project so that earned value gives you better results. Let's look at some of those conditions. If you set up your project to use short duration tasks, generally 1 to 2 weeks, and if you have many of these short duration tasks ongoing at any one time, then you would have tasks that you have underestimated the amount completed and other tasks that you've overestimated the amount completed at any one time. If you have a large enough number of these tasks ongoing at one time, then the number that you've overestimated and the number that you've underestimated begin to cancel each other out, and you're left with what comes close to a workably accurate understanding of the project's overall status. Yes, any particular task may be a bit off, but overall you've got a good understanding of where the project stands. But beware, there are known problems with the 50-50 rule that you really need to be aware of. Let us assume that you've assigned a project deliverable to a subcontractor, and you have created a contract in such a way that you use incremental payments at the 25% complete, 50%, 75%, and 100% complete points to motivate the subcontractor. You are concerned that if the subcontractor was to collect most of the money for the deliverables, they might not be motivated enough to finish the job, and thus you feel this incremental payment system is a way to reward the contractor for completing work while still motivating to finish off the rest of the project. You and the subcontractor have agreed upon a work breakdown structure and that you will use the 50-50 rule for determining value added to a project. Now let's see what can go wrong with this approach. With such an arrangement, an unscrupulous subcontractor might try and assign a worker to all tasks for just a few hours to conduct some research, but in doing so, the work has begun on the task, and thus all tasks would be considered started for the purposes of earning value towards the overall project. Having claimed to have started all the tasks, the unscrupulous subcontractor might now feel that they have claim for both the 25% and 50% incremental payments. Furthermore, in their mind, they might think that only minimal effort is now required to finish off a few of the tasks and thus open the door to the 75% incremental payment. With such an unscrupulous subcontractor, it would now become questionable if they would consider the work required to finish the deliverable worth the outstanding 25% final payment. Clearly, this is not what you intended, but don't worry, it's easy to fix. The 50-50 rule awards equal value to both starting and completing a task. If you wish to assign more value to actually completing a task, then they alter the way you assign value on the project to reflect your priorities. For example, you could assign only 25% value for starting a task and 75% value for ending one. This still has a motivator for starting new tasks, but places greater emphasis on completing one. If this is still not enough, then only apply 10% for starting a task and 90% for completing a task. If you don't see any value in starting tasks but only in completing them, then again change your rule to be the 0-100 rule, where all emphasis is putting on completing a task and nothing is awarded for starting new tasks. The takeaway is, before trying to implement your earned value system, make sure you think out how earned value will work effectively on your project, and in particular, how will you award earned value. This completes our look into earned value, but before I wrap up, I just want to say a word or two about how earned value is being used in today's workplace. Earned value is now frequently showing up on dashboards as part of automated information systems, more so now that these systems are becoming less expensive and easier to integrate into existing project structures. A quick search of the internet shows that people have found very clever ways to use the earned value formulas and concepts in dashboards of various types. While these displays can be fun to look at and show a great deal of imagination, you still need to know the concepts behind the information that they are presenting and how to interpret that information. For example, often you need to dig through the documentation for these systems before they will tell you such basic information as what rule is being used to determine how value is being added to a project. Without such basic information and an understanding of how the different rules affect the result, the information in these displays can be misleading. So to wrap up, earned value is a wonderfully powerful project management tool, and it works best within a fairly stable environment where you understand what the WBS, or the work breakdown structure, is for the project. Once you understand the earned value framework, it becomes a very powerful tool to present and convey project status to the various stakeholders on the project. But earned value is a bit of a skill. You need to practice before you can make it work effectively for you. And that is the presentation. Most students find earned value to be one of the more challenging subjects in studying project management. But hopefully this video has helped to dispel some of the mystery behind earned value and will give you a good start in understanding how it can be used on a project. So once again, my name is Bill Bowen, and I hope you found this video to be useful and beneficial. If you're one of my students, I look forward to assessing and providing feedback to you on your status report. And if you're not one of my students, then I hope this video has been helpful for you to understand earned value. In leaving, I'll once again post the slide with the formulas that were used within this video for you to review. If you liked the video, I have several others on various project management topics. I encourage you to check them out.